Bismillahirrahmanirrahim. Again, welcome everyone. And today we are going to start the next topic of the chapter gases. That is the general gas constant having symbol R. Now, what is general gas constant? According to general gas equation, PV is equal to nRT. Now, what will be the R? That is equal to pressure into volume divided by number of moles into absolute temperature of the gas. So you may say that it is the product of the pressure and volume of the gas. It is the ratio between the product of pressure and volume of the gas and the product of number of moles and absolute temperature of the gas. This one is the formula number 1. Now let us look deeply actually what does this formula of the R means. We know that pressure is actually force per unit area and volume is equal to area multiplied by length. So putting values or formulas of pressure and volume into 1, we will get R is equal to force per unit area multiplied by area into length divided by number of moles into absolute temperature. Area is cancelled and R is equal to force into length divided by number of moles into absolute temperature. And we know that force into length or force into distance, that is work. So R is equal to work divided by number of moles into temperature. This simply means that the general gas constant is the actually work done to raise the temperature of 1 mole of a gas to 1 Kelvin or 1 degree. So general gas constant, value of the general gas constant, it tells us that actually how much work we will have to do to raise the temperature of 1 mole of a gas up to 1 Kelvin. And the value of R has different values and they depend upon value depends on the units or dimensions used for pressure and volume of gas. Now let us find different values of the general gas constant. Suppose that we have 1 mole of a gas at STP standard temperature 0 degrees C or 273 Kelvin. Pressure is 1 atmosphere and volume is molar volume, putting all these values in 1. Now let us put all these values in 1. R is equal to, pressure is 1 atm, volume is 22.414 decimeter cube, we have 1 mole of gas and temperature is 273 Kelvin. Now when it is solved, the value comes out to be 0.0821 atmosphere decimeter cube per mole per Kelvin. This one is the value of R which is most commonly used in the numericals. And here what is meant by the atm decimeter cube? This one is actually the unit of the work or energy. So if we have 1 mole of a gas and we want to raise its temperature by 1 Kelvin, then 0.0821 atm decimeter cube energy is required, or this is the amount of work that will be held to perform. Now similarly, this can also be written as 0.0821 atm liter per mole per Kelvin, because liter and decimeter cube both are same. Similarly, it is equal to 82.1 atm milliliter per mole and per Kelvin, because 1 liter is equal to 10 raised to power 3 milliliter. So this value is multiplied with 10 raised to power 3 and we will get the value in milliliters. Similarly, R is equal to 62.4 millimeter of mercury decimeter cube per mole per Kelvin. In order to find this value, you will have to multiply this number with 760. Why? Because 1 atm is equal to 760 millimeter of mercury. And 1 millimeter of mercury, that is equal to 1 torr. So R is equal to 62.4 torr decimeter cube or liter per mole per Kelvin. But if we want to convert it to milliliter, then 62,400 torr milliliter or centimeter cube, because both are same, per mole per Kelvin. Similarly, now this one is very important for MCQs and short questions. System international value of general gas constant R. For this purpose, R is equal to, in system international, you know the unit of the pressure is Newton per meter square or Pascal, and 1 atm is equal to 101,325 Newton per meter square, or you may say Pascal. You can also write it down that 1.01325 into 10 raised to power 5 Newton per meter square. The system international value of this molar volume is 0.022414 meter cube. Quantity, that will remain 1 mole, because mole is the unit of the system international, and temperature also remains 273 Kelvin. When you will solve it, it will come out to be 8.3143 Newton. Meter minus 2 and meter cube, it becomes meter per mole per Kelvin. And you know Newton meter, that is equal to joules. So you may also write it as 8.3143 joules per mole per Kelvin. Now look at this, that it is the value of joule which will be required to raise the temperature of 1 mole of a gas up to 1 Kelvin. And you know 1 joule is equal to 10 raised to power 7 X. So R is equal to 8.3143 into 10 raised to power 7 X per mole per Kelvin. And we know that 1 calorie is equal to 4.18 joule, while 1 joule is equal to 1 divided by 4.18 calories. So in order to convert this value to calories, you will have to divide it with 4.18 or you will have to multiply it with 1 by 4.18. So R comes out to be almost 1.97 calories per mole per Kelvin. So here are the different values of the general gas constant R. This one is a constant, but we take it into different values, or we consider its different values. Why? Because the value of R that we use in any numerical, it depends upon the units of the pressure and volume that are already mentioned in the statement of the question. So if the pressure is in atmosphere and volume is in decimeter cube, you can use the relevant value of the R instead of converting the pressure and atmosphere into some different unit. So this one is the application of the general gas constant. This much is enough till the FSC level. I hope so that it will be informative for you people. Thank you so much. Allah Hafiz.